Good morning. I'm Diana and I will introduce a tool for air cargo planning and distribution.
Nowadays, any industry aims to avoid waste by making the most of resource available to become more efficient and competitive. We live in a dynamic world where every business is in permanent evolution. To use new technologies means new challenges in freighter transport and will help determine how transport is managed from origin point to destination. For freighter forwarders, cargo allocation problems due to their high complexity present a great challenge for companies whose core business is directly related to the use of space for shipping goods. Good planning is essential to minimize operating costs and improve performance. Cargo allocation on cargo planes can be done without any type of computation by someone experienced. However, the quality of load planning will depend on the experience of the planner. The high competitiveness of the cargo transport sector makes it necessary to define strategies that allow the optimization of all the resources as well as the maximization of the profits. Operations related to cargo transport involve a complex combination of information and flow of goods at different stages of transport chain. These stages are customs inspection documentation, consolidation of unit load device, transport, and other necessary operations related to material movements. To optimize the work in the cargo transport chain, it's necessary to understand who the main players are. There are four groups with active participation in the transport chain. These groups are made up of airlines, cargo terminals, handling operator, and customers. The relationship between these four groups is represented in image 1. Since the problem of cargo selection and allocation in transport is an important problem, it has received special attention. Manja presents a model that only considers maximizing the cargo carried on an aircraft, taking into account that the cargo transport will influence the plane's centers of gravity as well as the fuel consumption. Manja presents a formulation that aims to know what position to assign to each compartment or if on the other hand it shouldn't be loaded. For this, it's necessary to define the variables that influence the solution. To solve the problem, the weight by cargo loaded on aircraft is given by equation 1. Another important factor is the plane's centers of gravity after it's loaded. The center of gravity can be calculated by equation 2. The problem was studied in a company of the freight forwarding sector, which operates from airports in Europe, mainly in Spain, and ship to the whole world. For planning and distribution, there is a set of contracted aircraft exclusively for the cargo transportation. The planning is based on forecasts launched by the company, with the volume to be transported to its destination. The distribution must be carried out in 2 weekly cycles, that is, the goods must be delivered to destination 2 times a week. If the contracted aircraft don't have sufficient volume to transport all cargo, it's necessary to hire extra space to ensure that all cargo to arrive to destination on deadline. Different destinations have different shipping rates depending on the airline and the existence or not of a contract with the company. The company's main objective is to find the combination of volume for its destination to transport in different options so that the transportation cost is minimized, considering that the planes contracted by the company have the minimum cost regardless of the load to be transported. To formulate the problem, it was necessary to define the variables that directly influence the problem solution. There are 6 variables that we consider that influence the solution. For this problem, the decision variables are volume of cargo to be transported to each destination on contracted aircraft and the volume of cargo to be transported to each destination on non-contracted aircraft. For this problem, the objective function is represented by equation 3. The restriction, the first and second, guarantee that the minimum price for the contracted aircraft will be paid, that is, the price to be paid for the contracted aircraft will be the maximum between the minimum price to be paid for the contracted aircraft and the price to be paid for the transported cargo. The third restriction will ensure that the cargo to be carried on each contracted aircraft doesn't exceed the maximum capacity. The last restriction ensures that the volume transported between the contracted and non-contracted aircraft is at least equal to the value of the forecast volume to be sent to each destination. To obtain a solution to the problem, an application was developed. This application is relevant since currently the problem is solved by experts without any planning assistance. The input required is the volume to be transported to each destination. All other variables are related to contracts made and must always be updated by the quality department. The planning button will use the algorithm to present an optimal solution for the cargo planning to be transported entered by the user. The solution is represented as it shown in this video. By running the application, the user immediately has access to the cost associated with transport of all planned air cargo displayed in the lower left corner of the interface. To better understand the benefits of using the developed application, it was benchmarked in the 3 real problems corresponding to 3 work cycles. Each problem was solved by planning a method that is currently used by the freight forwarding company and the application developed. Table 1 shows the volumes to be transported in 3 consecutive cycles. The results for this problem are shown in Table 2. The amount paid with manual planning by the company in the respective weeks and cycles, and the amount that would be paid with the developed tool and the possible gains if this application was used. With the results presented in Table 2, we can say that only in 3 shipping cycles, the use of the tool developed for export planning allowed the customer to save about €36,825. This represents a gain of about 2%. The significant gains obtained only in 3 uses of the developed application explain the advantages of using it. It's easy to use and understand. The fast planning ensures an optimal solution, which allows a significant improvement in the work of the operational team, making it more efficient, real gains in a short period of time, and faster and more assertive customer response capacity. Like any other industry, the freight forwarding sector has been working to become more assertive and quicker in responding to the market with the use of new technologies and more efficient planning. The cargo allocation problems have been given special attention by companies that aim to minimize operational costs and improve their performance. Through mathematical modeling and the use of optimization algorithms, it was possible in just 3 work cycles a gain of about €36,825. Other advantages were achieved with the work developed, such as the reduction in the response time to the customer and an increase in the efficiency of the operational team. Thank you for your attention. Goodbye.